the speaker, Mr. Divakaran K, who will speak about invasive species as valuable resource for biomass. I now request the speaker to begin. Thank you.
Should we wait for more participants to log in?
No, this meeting is being live streamed on the website. So participants are available on the website. And as the meeting progresses, the participants can also join on Zoom as well.
Okay. Good evening, everybody. My name is Divakaran. I am the Vice President of Acclaim Technology Services Private Limited. We are into biomass gasification. Renewable energy solutions is what we provide. And from biomass, we have now moved on to biogas because that is the current trend. So since 1984, we have been in the business of renewable energy, providing alternate solutions to fossil fuels. Today, we are talking about climate change, and these are essentials what we have to go through. So I will take you first, before I go into biomass, I will go through this invasive species that are becoming a problem to us. You must have heard the High Court of Tamil Nadu of Madras giving instructions that the invasive species should be destroyed. But they have not given alternate what to do with the destroyed species. Now we have only two options: either cut them and mulch them or burn them, both of which are no do for climate change. So we are basically trying to address the climate change, and we are contributing it to it. High Court's decision actually contributes to it. See, when we burn it, we are putting carbon dioxide into the atmosphere. When we are mulching it, it evolves methane gas over a period of time. And methane gas, as you know, is 20 times more dangerous than the carbon dioxide. So what are these invasive plants which we are trying to destroy today? We will go one by one. This is an elaborate one, which I will share it for you all to read later on. I'll just run through that so that you get an idea. Number one is the Juliflora. So I will take it out. So this is Juliflora. You must have seen this on the roadside. Everywhere we will see this. And this is what the government has asked to destroy. If you look at it, this species flowering tree or shrub in the family of Fabaceae, commonly referred to as the mesquite, that can reach a height of up to 15 meters, tall, often smaller, in arid regions. It is native to the Americas and has been widely introduced in many tropical and subtropical regions around the world.
Sir, sorry to interrupt you. The PDF has not opened.
PDF is not opening.
You can stop and restart it. Stop sharing the screen and restart.
Okay. So this is the Juliflora tree. This is what you have seen. Is it sharing now, madam?
No.
Still no?
No. So maybe you can stop and restart.
Okay, now I'll share it. So here we start. Now
it has come, yeah.
Yeah. So Juliflora is what you see all along when you go in train, when you travel in bus, everywhere, wherever you see arid lands, you find that this is the tree. This was introduced in the second planning period as a resource so that the poor families can collect the wood and use it for cooking. Over a period of time, it has occupied so much of our lands that it has become a nuisance value. And today we are talking about a High Court order to destroy these invasive plants. The leaves of this will be this way, and it also flowers. Propagation is by that. And then you see the pods also. These are all resources because the pods can be used as biomass, the leaves can be used as biomass, the branches are a good source of firewood. and it has got better calorific value also. Now, the next series that we are talking about is the water hyacinth. You must have seen this occupying the entire water bodies. It's a very dangerous species because the oxygen levels are destroyed. The fish and other waterborne lives are lost, and also it destroys our water bodies. It's a flowering plant, beautiful flowers, but then at the end of the day, our water bodies are getting depleted because of this, and removing that is a big nuisance. And the third one, which you are familiar with, is the Parthenian. This is also, in fact, in Karnataka and all, government was paying people on a kilogram basis when this was destroyed and brought to the government for destruction. So now what we are going to do is, instead of destroying it and burning it or mulching it, we have to look at it as a resource, as a biomass. Now, when we look at it as biomass, we have certain advantages. So this is where I am going to take you through. So biomass is something, these items which we are destroying and wasting it off, they are a good resource as biomass. Now, biomass means something that can burn. Now, what we are bringing in is a technology called the gasification technology. There are many technologies. The biomass can be used by burning also, but then we are talking about a gasification technology because over a period of time, when you go through this presentation, you will understand what are the advantages. So here we are using this gasifier can deliver either thermal energy or the energy can be converted into power. In 1984 and in that period when we were looking at it, these things were available for free. Over a period of time, people have come to understand the value of biomass because it was a substitute for coal, and then the prices of this started going up. So biomass is a resource definitely, but then this invasive species is what we have to consider as biomass because it is still available on at a considerably lower price. Electricity from biomass is neutral carbon emission. Save the earth, reduce global warming. That is what we are all trying to address now. Fossil fuels are limited and we will exhaust at any time. See now, coal, crude, these mines over a period of time after exploitation, it will not lose its, there won't be fuels available for you to excavate. Then we are talking about corporate social responsibility, where we can convert, instead of coal and crude, we can look at renewable energy options. When I'm talking about fossil fuels, we also have to consider diesel, petroleum products also. Now, this topic is focused on renewable energy, the energy that can be used again and again and will never run out, like wind, solar, hydro, garbage, biomass. Our focus here is basically on biomass. Maybe over a period of time when agricultural information wishes, we can touch all these subjects one by one because each one is a subject by itself. So in this, we are going to focus on biomass, especially this invasive species destruction and use as a resource. So the definition of renewable energy derived from resources that are naturally regenerative or are particularly inexhaustible, such as biomass, moving water, hydro, and wind energy. Municipal solid waste may also be considered as a source of renewable energy because it gets generated every day. Green energy is the answer to climate change. So what are all the green energy sources? One, wind power. This is common. Solar, hydro. Now, if you look at these three renewable energy resources, you will find that wind is not always available. Sun is not always available. So the reliability of these things when you need it is not there. So we have to use it as it is generated, or we'll have to find a source to keep these generated items for future use. That is why it is a renewable energy, but not a reliable energy. Then hydro. Here we can pre-plan the requirement of hydro energy because when you open the water, this generates power through the generators. So you can decide when to open, when to close, and you can sync it with your other systems so that it is more reliable as an energy resource. So now coming to biomass, which is our core subject today. This is a new carbon neutral because it grows, we are cutting it and using it. These invasive species especially are available in plenty. So these are the conversion chart from which we can get it. Thermal conversion can be done through pyrolysis, gasification, and combustion. Biological conversions we can do with fermentation and digestions. That is what normally is the biogas. Then we can have mechanical conversions, and the products that we get out of each is given here. So these slides, I am sharing these things after this. This will be available for you to go through that at leisure, because I know this will be a short session where every answer won't be available, but still we can try to give you as much information as possible to build on it. So looking at biomass, we have heat and power. This is what we are focusing today. So gasification plus gas engine, boiler plus turbine, co-firing with coal, and biogas engine. So these are the outputs which can give you the energy that is required and for our use. So what are the resources? I have the start of this meeting, we have told about the invasive species which they are trying to destroy because they are creating problems for the environment. But other than that, these are all the resources. We have forestry, crops and residues. We have agricultural residues and crops. See, any agricultural produce, about 25 to 30% is what is available for human consumption. The rest is actually a waste. You look at rice, paddy, the straw is a waste. Similarly, cotton, cash crops, bagasse, all these are actually waste materials. So that is a resource, a biomass resource. Sewage, municipal solid waste, animal residues, chicken litter, cow dung, industrial residues from press mud, all these things. What constitutes biomass? Agri waste like rice, oats, hulls, rice straw, chicken, turkey litter, tree waste and sawdust. So you see the scope of biomass is very large. The technologies that we employ is really, we have to look at the source of raw material and the end applications, and depending upon the customer requirements or our application requirements, we have to design that. These are all technologies which as consultants we can say which will be the best applicable for you. If you look at gasification, these are the types of gasifiers that are available: updraft, downdraft, fluidized bed, entrained bed. So these are technologies which can deliver the energy that you require. Each has got its own advantages. It has got its disadvantages. And the application is what decides what is the technology to be employed. Biomass to gaseous form by partial pyrolysis, oxidation and reduction under subgeometric conditions. That is, we are going to limit the oxygen supply, and then under that conditions is what we are going to get this energy out. Biogas has been there in vogue even in the Second World War. Buses and tanks were run using this gasification technology. The composition is basically hydrogen, carbon monoxide, CH4 and carbon dioxide and the balance. But our focus is here on carbon monoxide. This is the real energy that we are going to get. Producer can be used for thermal applications, power generation, or a combination of heat and power. I will tell you the advantage of using it for thermal applications will be very high. At the end of the lesson, end of this presentation, I will tell you why. If I forget, you can also put that question to me, why thermal application is more beneficial. So we can replace diesel or fossil fuels in all these items. You can think about all where this application is, and based on your knowledge, you can suggest them to get into renewable energy in these areas. Typically used in melting iron steel, because we can go up to temperatures, we can go up to 600 degrees, we can go. And when we are using it in combination with other fuels like biogas or diesel, we can take it up to 1000 degrees. This producer gas, that is the gas that comes out of this thing from the volatile gas. This can be used in 100% gas engines which are available in the market today, or modified diesel engines. If you are already having diesel engine, that can be modified to give you to continue to run the same engine. But then there will be a derating but that can be addressed because the capital investment on that is reduced to that extent. The efficiency levels we are just giving this for your understanding only. So this is how the heating applications in a textile processing industry. Flue gas available from the engine and the engine jacket water can be recovered to a direct fired van and used for refrigeration and air conditioning. This is an area where a lot of exploitation can be done. Great savings can be achieved. Cold storages, because here the energy requirement is very high. So using a vapor absorption machine, we can get these things going at a much cheaper rate. Malls and multiplexes, air conditioning can be attempted through gasification system. Local power generation, because ideal for biomass will be the movement of biomass is an issue because it's a low calorific value item which we have to use diesel to transport. So it makes a sense that we use the locally available biomass locally. So the ideal sizing of the biomass gasifiers for power will be up to 3 megawatt. That's our suggestion. 25 kilowatt to 3 megawatt is possible. Now in gasification, we have a residue about 8 to 10% depending upon the raw material, which is known as biochar. This biochar is what world is talking today to enhance the production of agriculture. Our field trials have shown 25 to 30% more yield when it is applied to the soil in a particular ratio. We have done this experiment for vegetables, we have done for rice, we have done for sugarcane, and invariably in all these things, we have achieved 30% better yield. So these are all the biomass, non-food resources of biomass feedstock. So this must be catching your imagination. See, this much of things are wasted, which is really a resource. Coconut shell, rice husk, sawdust, groundnut shell. These have alternate use also. We can convert ground shell, sawdust, and rice husk into briquettes and use them also. Coconut shell, I'll get back to you. This is a separate subject in itself. Coconut shell is converted into shell charcoal or activated carbon. The byproduct in when we are converting coconut shell is either shell charcoal or activated carbon. Now, both of which are valuable product. So if we can find a buyer, if we can find a place or an industry where we can use this energy, thermal energy, this coconut shell cost can be hedged. So almost we will get this energy for free because coconut shell and shell charcoal, they go in tandem. The price goes in tandem. So that will hedge the price of the raw material. So your thermal energy will be almost free when you go from coconut shell to shell charcoal and energy. Cocoa shell, sugarcane, bagasse, trash, see the amount of waste that is available for biomass. Bamboo, juliflora, casuarina, eucalyptus. This juliflora is one of the subjects that we have discussed today, which is an invasive species which government wants to get it destroyed. Plantation prunes in plantations, tea, coffee, cardamom, pepper vines. These are all biomass resources. This can be mulched and used for as biomass, either briquetted or directly used as in co-firing with coal. These are the carbon cycles and how pyrolysis and biochar can work in tandem to get the soil amendment at the same time energy. So come, let's go green and contribute to reduce global warming and ensure that we bequeath a clean earth to our future generation. So you have any queries or anything? We will look at the solutions. That is the best thing that we can do today. Today, what has happened is that biomass has become a costly product. See, we started off with briquetting when sawdust was available almost free. we were sometimes paid to remove this sawdust, because unless we remove that, they could not do their production the next day of lumbering. But today what has happened is they keep it there and ask us for to quote for that particular waste. So prices have gone today. I think the price of sawdust ranges between 3,500 to 5,500 rupees, depending upon the moisture content. So this is it, madam. We can take questions. I think I have made it clear. So we can close this and go in for question and answer if you think that is okay.
If you'd like to put some more light, you can continue. We have another 6 minutes to go for 30 minutes.
Now, these are the things. See, now, if you Google and see this invasive species, they are a real danger because they won't allow other plants to grow in the vicinity. But we can grow them under conditions where that can be converted into a regular biomass with value, even in arid lands, because it requires very less water. Similarly, water hyacinth, it has got very high moisture content in that. So we can remove it. There are machineries available which can remove them. We can dry them, pulverize them, and use it for briquetting, or directly use that as a resource for biogas manufacturing. Today, under SATAT scheme, up to 2 tons, government of India is oil companies are prepared to take the biogas directly from us if we can fill it up in cylinders and give it to them. And another advantage is this biogas from any of these waste, the small sizes, right? Let us say from 50 kgs to 2 tons. If we can have inputs of regular inputs, this biogas can be used directly without cleaning in our heating requirements. So biomass as a resource is what our focus was. And I think I have addressed this invasive species, which we are trying to destroy, as a valuable resource for gasification and power and thermal. Now, I was telling you about why we should avoid power and go for thermal. See, now, in thermal energy, when we are converting this gasification and going to use it as thermal energy, we are replacing it either for gas or for diesel. Now, 1 kg of 1 liter of diesel will, in a generator, will give approximately 3¼ units of power. If we look at the power cost today, even if you take it as 10 rupees, the cost of power is only 35 rupees. The value of power, when we convert biomass to power, is only 35 rupees. For that, additionally, we need a gas cleaning system before it goes to the generator. And then there is a generator maintenance cost. So if you look at that, the power cost or the realization cost is only maximum 35 rupees. But suppose if you are able to replace this gas 1 kg with 1 kg of LPG, then your replacement cost comes to around 100 rupees. So 35 rupees versus 100 rupees. To get 35 rupees value, we have to make an investment for cleaning the gas. Then we have to make an investment for the generators. Whereas in thermal energy, we are directly using it for thermal energy, either as for burning or for gas directly for hot air, whatever it is. So the replacement cost, if you look, is the benefit that we get from the same kg of producer gas will be either 100 rupees as gas replacement or 35 rupees after all this investment and maintenance as power. So that is the reason why I say it's always better to use it as thermal energy. But if we are in a place where energy power is not reliable, then we can go in for this combined heat and energy, because the waste energy that is coming from the flue gas and the engine heat is what we are converting. So there we have value addition to it. This both the topics I have already put it in WhatsApp to you, madam. You can upload it so that they can look at leisure, and my email ID is also there. So they can send me their queries, and I will assure you that within 2 working days, I will try to answer them. And I'm always available on WhatsApp.
Yeah, okay, sure, sir. There are some, not too many questions, some simple questions only. So there is a talk about in the whole world about global warming. So what solutions are there to solve this problem?
See, global warming first and foremost is we have to address this issue of reducing the consumption of fossil fuels. So can we do it? What are they? Coal, diesel, petroleum products. Now, is this a substitute? Yes, because we are not going into destroying the food crops or commercial crops. If we are doing that, then yes, we are doing bad to the society, because we are getting into the domain of eating and commercialization. But what we are actually taking out is the waste, what we are not consuming. For example, if we are taking coconut, we are talking about the coconut shell. If we are talking about rice, we are talking about the rice husk. If we are talking about cotton, we are talking about the stalks. If we are talking about sugarcane, we are talking about the trash and also the bagasse. So bagasse, of course, has got alternative. We can use it for making paper. But then if you look at the industry waste from the sugarcane industry, press mud, a normal sugarcane industry produces around 270 to 300 tons of press mud at 70% moisture, which is a good candidate for power generation. It can be converted into biogas. So climate change, who has to address this? Either NGOs with money, because all these things require additional investments. I'll give you a biscuit company, which was using around 2,200 liters of diesel per day. We could replace that with 12 tons of coconut shell. And as I told you, the coconut shell is converted into, so which is the main product, coconut shell or power? So that is a question. Both of them are valuable, because when I am converting coconut to coconut shell, I get 30% coconut shell charcoal. Today, if you are looking at coconut shell price and shell charcoal price, it is almost 3.5 times the price of shell. So if coconut shell is available for 10 rupees, then shell charcoal is about 35 rupees. So that means 3 tons of shell, if I buy for 30 rupees and convert it into shell charcoal, I still get 35 rupees. And energy that I get from it is almost free. So these are the things that we have to look at and really work. So how can we work together? Who are the people, pioneers who can help us to do this? Energy consuming industrialists have to come out with a CSR program to see, sorry, to see that these things are, we are using them profitably and replacing these fossil fuels. We can give them packages where both of this can coexist, so that reliability factor improves. See, unlike wind or unlike solar, this is available on demand. We can plan it. So today, if I have to bring in coconut shell and give you power, I have to just stock the coconut shell, and you can be assured, unless there is a problem with the system, plant and machinery, this is going to generate the power that we are guaranteeing. So this biomass to power is a reliable, renewable energy resource.
Okay.
And today technologies have grown so much that 1 kg of biomass can give you almost 1 unit of power.
Okay. So next question is, how can we get this biomass?
Biomass is available in plenty, madam. Today we are talking about with big companies where they have got big land masses. So these land masses have to be cleared and put to proper use. So what is the first question that arises? To clean the waste growth that is there. The entire waste is a resource. This is a biomass. So now we are talking to some cement companies. We are talking to Vedanta. They have got land banks and we have given them proposals. But then who will build the cat? They have to come with the resources. Now, cleaning up an area is a cost to company. They have to, who will build the cat? And then we have to convert that into resource. Your power plants need them. Your cement plants need them. We are only looking at biomass which is available and which is costing you, like sawdust. We have to forget that. We can go in for other biomasses like crop waste, which is from either commercial crop waste or food crop waste. So this has to be organized. See, today we are talking about stubble burning and the problems of pollution in North India during winter season. You are aware of that?
Yeah.
Yeah. Now, what is the issue? Now, between the crop that is ending and the next crop, the farmer has got only a 25 to 30-day window to clean up his land. Now, just imagine he cleans up this land, there is a cost to it. And he has to convert it into a bundle and then carry it to the nearest station for converting it into biomass. Now, this cost is not hedged by the, this expenses is not recovered. Now, what is to be done? The government has to step in and we have to create a resource center where we will tell the farmers, okay, boss, your season is over. Just inform us. We will come with the vehicle, collect this biomass and convert it into usable form of biomass where this can be used along with coal. Or we can convert the whole thing into biochar and give it back to the farmer. Let us assume he gives me 5 kg of biomass. I give him 1 kg of biochar, which is a valuable product for his land. It improves his carbon content. It gives him better yield. His soil is getting, soil sequestration happens. And the balance 2 kgs will give me my profit to convert it into briquette or to generate power. Or tie up with an industry to give them the thermal energy that is required. So these are efforts. These are to come from the industry, from the government, and people like us, technology partners. Because technology partners do not have the money. We come to you with technology and we are prepared to handhold and see that this is becoming a success. But then the right earnest way of putting this into practice, these initiatives have to come from the government and the larger industries.
Okay. So next question is how easy is to convert biomass to power?
Madam, it's like any other industry. See, the biomass preparation is the basic thing. Now, certain things come to you as prepared biomass. For example, sawdust. You can directly use it for briquetting or with other things. But then other things, tree branches, you have to convert them into, you have to mulch them to, let us say, if I have a system where I can use 50 mm of this biomass, I have to ensure that these are mulched to the system. So this biomass preparation is important, which is, there are a lot of technologies. And that is a cost to company. And when I say biomass to power, these costs are all taken. Biomass preparation is the basic requirement. See, for example, bagasse. Bagasse can be shredded. The trash of sugarcane, that can be shredded and converted into biomass. So biomass preparation is a subject. So after biomass preparation, then we come to the conversion. And then from the conversion to the energy. And then the usage of energy. So these are all segregated and well organized systems. There is no issues. And this is the most reliable way of working with the biomass.
Okay.
The moving parts are much less compared to other industries. So you have technologies which are fit and forget, like Ringling cycle.
Okay. So what about a small farmer?
Any farmer, madam, this is what, see, there is no small farmer or big farmer.
In the sense he may not be having the technical knowledge. So
they don't need, that is what I'm telling. The technical knowledge it's not a question of technical knowledge. He is the generator of biomass, as simple as that. Whether he is a small farmer or a big farmer, every farmer is a generator of food or a commercial crop plus biomass waste. So now, food item, he knows how to sell. There are many ways. But this residue item, he just burns it because that is the simplest option. Now we have to ensure that this waste is consolidated, and for that consolidation, who pays for the farmer? Now that is an additional income for the farmer. You just imagine, when you are making paddy, 30% of that paddy is sold as a food item. The balance 70%, he doesn't have value for that. Now I am prepared to give him a value. So that value should be equivalent to what is the amount that I'll be realizing from the energy. So this is where the economics of waste management comes. See, now if you burn trash in Australia, you will have to pay a fine of $150. Now what they do is, sorry, they have mobile vehicles which go to the farm, convert this into biochar and give it back to the farmer. And the farmer pays him $50 or $100. So now look at it. The fine is avoided. He is converting this waste into a valuable biochar and putting it back into his soil. Why the farmer? Why is he burning this stubble in the garden? Because that's the easiest way he can do. But is stubble adding value to his soil? Absolutely no. It is ash. Whereas when we convert that into biochar and put it back into the soil, he can be guaranteed at 25 to 30% more yield in his next crop. And the soil becomes more, the soil sequestration happens. When you are applying biochar to the field over a period of time, your application of fertilizer will come down. Your pesticide requirement will come down because the root system will have a strong soil to come, and the root system is strong. It has got a better root system. The insecticide attacks will come down. The immunity grows.
Okay. Okay. So next question is, please let us know a little about your career background and what made you to take an interest in this subject.
When we were looking at alternates in 1984, at that point of time, shell charcoal was available in abundance. And it was really not put to much use. So shell charcoal, converting it into shell charcoal was our idea. And we put up the first plant in Tamil Nadu, in India perhaps. In Tamil Nadu, we put it up as a 1 megawatt plant. And we converted this shell to shell charcoal, and that energy was used for generating power. At that point of time, excuse me, the price of shell was only about 1.5 rupees. And we could do a PPA. Government bought the power for 2 rupees 80 paise, I think. So that was a valuable proposition. Today, the biomass power maximum what we get in Tamil Nadu is around 475, I think, at today's price, because we have not been doing this for quite some time. And that is not a viable proposition. But if you are looking at this conversion of waste with the government intervention and High Court saying that this should be destroyed, then we have to look at that as a destruction cost should not be added to the value of biomass. If we consider that, then this becomes again a valuable thing. And then again, the buying, we used to give it to the grid and government has to pay us. Dealing with the government, I don't want to go into it in detail.
Okay.
The best thing is converting the biomass into thermal energy by using it as in co-firing along with your coal, or converting it into briquettes. Or some of them, like water hyacinth, as I told you, we can prepare them and convert it into biogas. Today, all oil companies are buying biogas. CNG, compressed biogas is pure methane, 92.5% methane. And if we are on the gas pipeline, we can directly evacuate this into the system.
Okay. Okay. So now we have the last question. What does your company, Acclaim Technology Services India Private Limited exactly do?
We are providing solutions for biomass and renewable energy in general, solar thermal, solar PVs. But our focus is more on biomass conversion as a resource and then providing solutions for thermal energy. I'm specifically again emphasizing on thermal energy because the reasons I explained to you earlier. That's the best way to put biomass use to, because we are substituting that for either coal, which is today about 5,300 calorific value. We are paying around 14 to 18 rupees. We are importing coal. Whereas this is a 4,500 kilo calorific value of biomass. We are selling it a maximum between 3,500 to 4,500. So value for money is there in biomass, but we have to consolidate this biomass and make this industry grow larger. We have to take this this knowledge to the villages.
Right. Yeah.
Because if you go in the train, if you go in the bus, you look around yourself. You are engulfed with this waste biomass. So you just imagine all this biomass is converted into energy. We don't have any energy shortage in India.
Yeah. Yeah. Okay. Okay. So, okay, sir, I don't see any more questions from our participants.
Thank you,
So,
madam. No, you can, both these things I have shared, you can share it to your clients, and anyone can write to me or call me. I am available 24/7 unless I am not reachable, and I will answer them. I'll assure you that I'll answer them within the next 48 hours of receiving it.
Sure, sir. Yeah,
In
yeah.
case I miss, they can call me also.
Yeah. Okay. Yeah. Thank you for the detailed, interesting talk, sir. So now we have come to end of question round. On behalf of agricultureinformation.com, we like to thank you for the talk, and we also like to thank all the participants for joining this meeting. The meeting will now be closed.
Thank you.
You're welcome, sir. Thank you.